Welcome, deep divers. Have you ever walked past a familiar building, maybe an old brick factory, now bustling with new offices, or a grand Victorian house converted into apartments and just wondered about its secret life?
Hmm.
We often tend to think of buildings as these solid, unchanging monuments, sort of frozen in time once they're completed.
Right, like they're finished. Done.
Exactly. But what truly happens to them after the architects leave, the last nail is hammered, and the construction crews tack up? Do they stay the same?
Or do they begin a hidden journey of their own? Adapting, transforming, sometimes even struggling, you could say.
It's a profound question, isn't it?
It really is. Because the conventional view of architecture, well, it often stops precisely at that ribbon-cutting ceremony.
Yeah, the grand opening.
Right. Assuming a building's story is complete once it's deemed finished, we celebrate the initial vision, the structural achievement.
But as we're about to discover in this deep dive, that couldn't be further from the truth.
Not even close. Buildings are living entities in their own right, constantly reacting to the world around them and, importantly, the demands of their occupants.
Exactly. Today, we're taking an extensive deep dive into this fascinating, often overlooked life of buildings. We're guided by Stewart Brand's incredibly influential and, frankly, revolutionary work, How Buildings Learn, What Happens After They're Built.
It's such a great title.
Isn't it? And his radical premise isn't just about erecting a structure. It's about initiating a narrative, a story that continues to evolve, adapt, and transform long after that final nail is hammered.
Yeah, Brand fundamentally shifts our perspective. He pushes us to consider a building's entire lifespan, not just its pristine debut.
It's a whole new way of seeing.
Brand's vision challenges us to see architecture not as a static object, but as a dynamic, ever-evolving process of adaptation and change.
A process. I like that.
And this perspective, it forces us to acknowledge the inherent impermanence and continuous evolution that every structure undergoes. Whether it's, a humble garden shed or a grand historic cathedral.
It applies across the board.
It really does. It's a powerful lens through which to view our built environment, moving beyond the idealized plans to the messy, vibrant reality of use and adaptation over time.
And our mission in this deep dive is to extract the most important insights from Brand's revolutionary ideas and the accompanying material you've provided.
Right.
We're going to explore in detail why some buildings seem to gracefully adapt to new uses, almost effortlessly shifting their purpose over time.
While others seem to fight their occupants at every turn, stubbornly resisting any change. You know the kind.
Oh, definitely. And you'll learn why truly designing for the long term means considering not just the initial construction, but also decades, even centuries of maintenance, renovation, and resilience.
It's about building in the capacity for a building to learn. That's the core idea.
Building it in from the start.
We'll uncover how some design choices, often made with the best intentions for, initial perfection.
Yeah, the perfect photo op.
Exactly. How those choices can unwittingly create obsolescence down the road. While others, sometimes seemingly simpler designs, actually lay the groundwork for enduring adaptability. It's about understanding the deep currents of time and how they interact with our built environment, shaping not just the aesthetics, but the very utility and longevity of our structures.
Ultimately, we'll ask a provocative question for you to ponder.
Yeah.
What if the absolute best practice in architecture isn't to design a finished product at all? Not a monument to a single moment.
But instead to design a building that is truly never done.
Yeah, a building that is always ready to learn, adapt, and change alongside its human inhabitants. What would that look like in practice?
And what responsibility does that place on us as designers, builders, occupants?
Lots to think about. Let's unpack this. Okay, so this idea of buildings being dynamic, living entities.
Yeah.
It really challenges our conventional thinking, doesn't it? We're so used to seeing them as permanent fixtures.
Completely. Brand's core idea fundamentally shifts how we see architecture. It suggests it's not just about erecting something, but about starting a story that continues long after construction.
It really makes you reconsider the role of an architect, doesn't it? Maybe less master builder and more.
Master gardener, planting the seeds for future growth.
That's a great analogy. It gets right to the heart of it.
Yeah, because the conventional view, it often stops precisely at that ribbon-cutting moment, celebrating the architect's initial vision as the definitive statement.
Final word.
But Brand argues, no, you have to see buildings as dynamic processes. Adaptation, change, it's constant.
So this perspective forces us to acknowledge the inherent impermanence.
Absolutely. And the continuous evolution that every structure undergoes, whether it's centuries old or brand new. The building's life cycle is far longer than its initial design phase, and often far longer than the lifespan of its first intended use.
So designing for that reality rather than fighting it.
That's Brand's central message. Embrace the change.
And to help us understand this continuous evolution, Brand introduces this brilliant concept of shearing layers of change. It's a very vivid image.
It really is.
Like imagine a building not as a single monolithic block, but as several distinct layers, almost like an onion.
Or geological strata.
Yeah, each moving and changing at its own pace, revealing different strata of time.
Yeah.
How does this framework actually break down a building? What are these layers?
Okay, so this framework is incredibly powerful because it helps us understand the different lifespans within a single building. It recognizes that not everything changes at the same rate, and these rates can vary wildly. Brand identifies 6 core layers, basically, from the fastest changing to the slowest.
All right, let's hear them.
First, you've got stuff. This is the most ephemeral layer: furniture, appliances, computers, personal belongings. Stuff changes constantly.
Right, months, even weeks. You rearrange your living room, get a new laptop.
Exactly. Then, layer 2 is the space plan. This refers to the internal layout, the walls, doors, ceilings within a floor.
Okay, so how the rooms are arranged.
Precisely. And that changes over years, maybe every 3 to 30 years as offices reconfigure or families grow. It dictates how space is actually used day to day.
Makes sense. What's next?
Layer 3. Services. These are the working guts of a building. Think electrical wiring, plumbing, HVAC systems, communications lines, elevators.
The functional systems?
Right. They have a lifespan of maybe 7 to 15 years, sometimes a bit longer, requiring updates, repairs, or replacements to keep up with technology and efficiency standards.
Okay, so stuff, space plan, services. Layer 4.
That's the skin. This is the exterior of the facade, windows, roof, insulation. It acts as the protective membrane against the elements.
How long does the skin typically last?
Generally 20 years or more, depending on materials and climate. It weathers storms and sun, often undergoing significant upgrades for energy efficiency or, aesthetic renewal.
Got it. 2 more layers left, the slow ones.
The slowest ones. Layer 5 is structure. This is the fundamental load-bearing system: foundations, columns, beams, load-bearing walls. This is the slowest layer to change internally.
The skeleton.
Exactly. Potentially lasting 30 to 300 years, often outliving several generations of occupants and uses. It defines the building's physical limits.
And the final layer, the absolute slowest.
Layer 6, the site. This is the slowest and most permanent layer. The geographical location, the legal boundaries, the excavation, the grading.
The land itself.
The land itself. This can literally last for millennia, long after any specific building has come and gone. The site remains.
Wow. So thinking about those layers, an office building that tries to make its internal layout, the space plan layer, rigidly tied to its structure layer, maybe with permanent load-bearing interior walls.
Yeah, that's setting itself up for constant conflict.
Right. And expensive renovations every time a tenant needs to rearrange. It literally fights against the faster-moving needs of its occupants. That's a powerful visual.
It really clarifies the potential friction points in a design.
Can you give us a concrete example of this shearing layers concept in action, where the flexibility of one layer truly saved a building from obsolescence?
Absolutely. Brand himself dedicates significant attention to the iconic painted ladies of San Francisco. Those colorful Victorian row houses in Alamo Square.
Oh yeah, everyone knows those. Beautiful houses.
Beautiful, yes. But what's fascinating here is that these houses were survivors, thriving for over a century, not because of their elaborate high-maintenance facades.
Really? Not the fancy gingerbread trim.
Nope. In fact, those intricate, high-style exteriors, which belonged to the skin layer, often required more care than was available, and many didn't survive events like the 1906 earthquake because of their vulnerability.
Huh. So what did make them resilient?
Their remarkable resilience came from a surprisingly generic and highly adaptable internal space plan, that crucial space plan layer.
So it wasn't the pretty, ornate exterior that kept them going, but the simpler, more functional bits inside. That seems incredibly counterintuitive, especially for Victorian architecture.
It does, right. But Inverness Moudon's Built for Change study, which Brand references extensively, highlighted exactly this. These homes had a remarkably simple, adaptable layout. Stairs and corridors on one long side, and a row of rectangular rooms opening off the corridor on the other.
Just basic rectangles?
Pretty much. This basic rectangular plan, free from highly specialized or oddly shaped rooms, allowed for continuous transformation and new uses over time. Even as ornate details like brick chimneys and leaded windows disappeared or were replaced.
The core layout remained flexible.
Exactly. Over their lifespan, these houses shifted from single-family homes for large Victorian families to multi-family apartments, then back to single-family homes with updated layouts and even to professional offices.
Wow, that's a lot of change.
It is. Their robust yet flexible structure and site layers provided a stable base, while their space plan layer could be easily reconfigured for successive generations of occupants. It perfectly illustrates how flexibility in the deeper, slower-moving layers, like the spatial arrangement, can allow the faster-moving layers, like finishes or room functions, to adapt without undermining the whole structure.
The building learned because its fundamental bones were accommodating.
Precisely, a testament to practical rather than purely aesthetic design.
That's a brilliant insight. It suggests that true architectural longevity might lie in intelligent humility rather than, flamboyant showmanship.
It often does.
And Brand then takes this idea of how buildings adapt and categorizes them into what he calls high road and low road strategies. It's almost like a tale of two philosophies within architecture.
Yeah, this distinction is quite elegant. And Brand draws a direct parallel to biological populations, specifically the R strategy of opportunist species versus the K strategy of preserver species.
Okay, biology lesson time. How does that work?
Think of dandelions as an R strategy species. Small, short-lived, focused on high productivity, rapid reproduction, scattering seeds everywhere. They're built for rapid change, quick adaptation, a certain disposability. They thrive in disturbed environments.
Okay, got the dandelions. What's the K strategy equivalent in nature?
That would be like an oak tree. Large, long-lived, investing significant energy in building and protecting its environment. Designed for endurance, stability, slow, deliberate growth.
Oak tree versus dandelion. Got it. So how does this apply to buildings?
High-road buildings are the architectural equivalent of those oak trees. They're characterized by high visibility, high style, bespoke design, and nearly always high cost.
The fancy ones, the monuments.
Exactly. These are buildings that are successively refined, meaning they are meticulously maintained and updated, often retaining their original form and unique character, even as they take on new uses.
So they accumulate history, layers of refinement.
Right. Their sustained complexity leads to rich specialization and unique character. They often retain obsolete oddities until creative new uses are found for them. Imagine finding a way to string new fiber optic cables through an old, disused laundry chute in a historic building. That's a high-road building. Finding a new, refined use for an old feature.
Huh. Okay, like a landmark corporate headquarters, a grand museum, a restored opera house.
Perfect examples. They accumulate history, almost like scar tissue and memories, becoming richer over time.
So these high road buildings are almost like bespoke suits, tailored, unique, requiring constant, careful attention to stay relevant and pristine. What about the low road buildings then? The dandelions.
Low road buildings, on the other hand, are more like the dandelions, or maybe a better analogy, like good quality, adaptable blue jeans.
Blue jeans, okay, I like that.
They are more humble, often successively gutted and begun anew. They emphasize adaptability, robustness, and ease of transformation over initial grandiosity or intricate detailing.
So they get changed around a lot more.
Yeah, they might be torn apart and reconfigured many times over their lifespan, but their basic, often simple and generic shell allows that flexibility. They are less precious, more utilitarian, and often cheaper to build initially.
Like a flexible warehouse space that becomes an art gallery, then a co-working space, then a pop-up market.
Exactly that kind of thing. The original structure might be basic, but its inherent neutrality allows for endless reinvention with minimal effort. This distinction helps us understand the fundamental design intent regarding longevity and adaptation.
That makes perfect sense. And Brand provides a compelling illustrative example for these high road buildings with what he calls America's biography houses.
Ah, yes, these are fantastic examples.
These aren't just old homes, but structures intimately tied to the lives of their famous occupants, right?
They are indeed extreme examples of high road buildings. Mount Vernon, George Washington's home; Montpelier, James Madison's; and Monticello, Thomas Jefferson's. All three are in Virginia, relatively close to each other.
And each is a classic biography house. Meaning what exactly?
Meaning it closely sustained and reflected the changing life situation of its main occupant and their family. Jefferson, in particular, famously and continuously tinkered with Monticello throughout his life, reflecting his evolving tastes, experiments, and needs.
So the house changed as he changed.
Precisely. These houses are, in essence, architectural autobiographies, embodying the successive refinements of their prominent owners. They wear their history on their sleeve.
And what's particularly interesting is why they remain so well preserved and continue to define the historical narrative. It wasn't just a conscious decision to make them monuments from the start, was it? There was an ironic twist involved.
That's absolutely right. While they are incredibly well preserved and cherished today, part of their astonishing longevity and preservation is due to an ironic twist of economic fate.
Economic fate. How so?
Well, the soil in those regions, heavily farmed with tobacco and other cash crops, was largely exhausted by the early 1800s,
Oh, okay. Bad farming practices.
which caused the plantations, and thus the families managing them, to fail economically. This severe financial limitation meant that little further alteration or grand, expensive renovations could be afforded by subsequent owners.
So they couldn't afford to mess them up, basically.
In a way, yes. The buildings were, in a sense, frozen in time, preserving their character through continuous use as living residences, rather than through major erasing transformations that might have modernized them or changed their fundamental character.
That's fascinating. So their high road character, the meticulous detailing and unique forms, was maintained because later owners were too broke to change it.
Largely, yes. The economic circumstances prevented later generations from fundamentally altering them. They became living museums of their occupants' lives almost by accident of economic hardship, allowing us to still perceive the accumulated layers of their individual histories.
Okay, so if buildings are going to learn and evolve over time, if they are dynamic rather than static, what does that mean for how we actually design them? It seems like a real challenge to the traditional idea of a perfect initial design.
It really is.
That idea of something conceived as complete and immutable. Does striving for that day one perfection actually hinder a building's ability to adapt later on?
Absolutely. Brand's work, and really broader architectural history, strongly suggests that designing for day one perfection can often be a trap.
A trap. How?
Well, the idea of a perfectly finished building can be an illusion, and maybe even detrimental to its long-term viability and usefulness. The goal, then, should shift from anticipating some immutable ideal to anticipating and accommodating the inherent messiness, the unpredictability, and the evolving needs of real life.
So design for a future you can't fully predict.
Exactly. It's about designing for that uncertainty, building in the capacity to change.
You know that feeling when you see a stunning building in an architectural magazine? Perfectly pristine, everything in its place, composed just right for the camera.
Oh yeah, the money shot.
Right. Brand suggests this magazine architecture can actually be a real problem for a building's future. It's designed to be photographed to make a grand statement.
But not necessarily to be lived in, or more importantly, to be changed over its long lifespan.
It seems to prioritize fleeting aesthetic trends over enduring functionality.
Precisely. Brand critiques this aesthetics of the moment and the real estate fads that produce buildings that look perfect on day one, but then fail spectacularly to accommodate future needs.
Because they're too specific, too fussy.
Often, yeah. He argues that prematurely convoluted surfaces are expensive to build, a nuisance to maintain, and hard to change. Such designs prioritize fleeting fashion over enduring function, often because they are created for a specific, sometimes highly publicized initial purpose with little thought for what comes next.
So what's the alternative?
The true challenge, Brand suggests, is to design structures that are honestly interesting in their own terms, freed from the constraints of a current vogue. The building should possess an inherent integrity and a certain spatial neutrality that allows it to evolve rather than be discarded or become a constant source of friction for its occupants.
Designing for a long, useful life, not just a dramatic debut.
That's the idea.
And we can see examples of this conflict, this friction, even in some of the most famous structures in history, where the original design intent clashed with later additions, making the building...
An enigma, as Le Corbusier put it.
Right, an enigma. A powerful illustration of a building literally fighting its own design and its occupants.
Indeed. Le Corbusier himself provides a really powerful historical example of this tension with St. Peter's Basilica in Rome, a structure everyone recognizes for its architectural grandeur.
Okay, St. Peter's, what was the issue there?
Well, Michelangelo, when he designed the enormous dome, intended it to be immediately apparent upon entry. It was supposed to create this breathtaking, grand impression, a clear visual hierarchy.
The main event, right away.
Right, the climax of the approach. However, later popes, driven by their own needs and visions, added 3 bays and a great vestibule to the front of the basilica.
They extended the entrance.
They did, and this seemingly minor change fundamentally altered the approach. It forced visitors to traverse a tunnel more than 300 feet long before arriving at the dome.
Oh, wow. So it completely changed the experience Michelangelo intended.
Completely. Le Corbusier argued that this addition fundamentally conflicted with Michelangelo's original vision, essentially destroying the whole idea of the building and making it an enigma. The intended clarity and impact were lost.
So the building, in a way, started to fight its own design and its visitors' experience.
Metaphorically speaking, yes. It became less coherent, less learnable in its narrative. This vividly illustrates how architectural changes, even by prestigious figures, can ruin the whole idea when they don't respect the core principles of the deeper layers.
That's a fantastic point. Seemingly grand additions can actually diminish a structure's learning capacity, making it less than the sum of its parts. So, if we're trying to avoid that kind of architectural conflict, what kind of form or structure actually helps a building adapt over time? It sounds like simplicity, maybe even a humble approach might be key.
Simplicity is absolutely crucial. Brand champions this with a rather blunt but profound directive.
Be square.
Be square, seriously.
Seriously, he states quite unequivocally that the only configuration of space that grows well and subdivides well and is really efficient to use is the rectangle.
Ah, I can imagine some architects groaning at that.
Oh, Brand notes that. He says it might make some avant-garde architects groan with boredom, but he insists it's a profound truth rooted in practical utility and long-term flexibility.
So why rectangles? Well, if you start with a boxy and simple form, both outside and in, then you can let complications develop with time, responsive to use. It provides a neutral canvas,
As opposed to
convoluted designs buildings with unusual angles, curves, or highly specific internal geometries. Those are inherently expensive to build and notoriously hard to change or adapt without significant structural intervention.
So simple, adaptable, rectangular forms provide a neutral, robust framework.
Exactly. A blank canvas upon which countless future space plans and uses can be layered without fighting the core structure. It's the ultimate low-road principle for enduring adaptability.
And a great historical example of this principle, of designing for internal flexibility right from the outset, comes from the legendary modernist architect Mies van der Rohe. He seemed to really get this, anticipating Brand's layers.
He really did. In the revolutionary Weissenhof housing settlement, built way back in 1927, Mies van der Rohe's steel-framed apartment house was a pioneering example of designing for internal flexibility.
What was so innovative about it?
What was truly innovative, and what made it a precursor to Brand's ideas, was that the steel frame allowed for the elimination of all rigid inner and outer walls.
So the structure itself created a blank canvas almost. No load-bearing walls inside, locking you into a particular layout.
Exactly. This meant that the inner walls can be disposed according to the liking of the tenants, in whatever manner they choose.
Wow, imagine that freedom.
Right. Tenants could reconfigure their living spaces as their families grew, their needs changed, or their aesthetic preferences evolved, without needing to touch the building's permanent structure or services.
That's proactive design for tenant-driven change, recognizing that people's needs evolve much faster than the building's core.
Precisely. It's a perfect embodiment of Brand's adaptable architecture because the core structure layer provided a highly flexible framework within which the faster-moving space plan and stuff layers could change freely, easily, and affordably,
Without having to fight the more permanent elements.
making the building inherently learnable and responsive to its occupants' lives.
It's clear that it's not just about the big picture design choices or the overall form. The very materials used and how they're put together at a granular level play a huge role in a building's ability to learn and endure, doesn't it?
Oh, absolutely. From the smallest joint to the largest wall system, everything contributes to its long-term behavior.
How so?
Well, the inherent properties of materials, the techniques of construction, and even the approach to maintenance fundamentally impact a building's long-term behavior and adaptability. Buildings aren't inert. They're constantly reacting to their environment and the forces within and around them.
And ignoring those dynamics at the design stage
Is a recipe for long-term problems, definitely.
So how do materials themselves move or change? What does that mean for how we have to design around those inherent properties?
Well, consider the inherent, often subtle movement of materials. Concrete and stucco, for instance. They shrink as they cure and dry out over months and years. The seemingly minor detail necessitates carefully designed control and relief joints in their design and application. Otherwise, you get unsightly or even structurally compromising cracking.
Right, those lines you see in concrete.
Exactly. And more broadly, all building materials expand and contract due to variations within the normal temperature range, as well as exposure to solar radiation and wind.
Everything moves with temperature.
Everything moves. To accommodate this relentless cyclical movement over decades, flexible, weather-tight expansion joints are crucial to prevent buckling, stress, and damage.
And wood. Wood must move a lot, too.
Oh, yeah. Even something as common as wood behaves dynamically. It's very wet when freshly harvested from trees and shrinks significantly as it dries.
So you have to account for that shrinking.
You absolutely do. Wood must be pre-shrunk, essentially dried to a moisture content consistent with its eventual environment before it's used. This minimizes dimensional change after construction, which can lead to warping, splitting, and joint failure.
So these aren't static properties. They demand continuous accommodation in the design.
Otherwise, the building will literally tear itself apart over time.
And what about managing water? That's obviously a major challenge for any structure over time, the eternal enemy of buildings, right?
Always. Water management is paramount for a building's longevity and health. Different rain screen wall systems, for example, illustrate various approaches to deterring water penetration.
Okay. What are the different approaches?
Well, on one end, you have traditional mass wall systems like solid masonry. They shed most rain but absorb the remainder, slowly drying by releasing moisture as vapor. They're robust but slow to react.
Right, like old stone walls.
Exactly. Then you have barrier wall systems. These rely on a continuous, perfect seal at the exterior face to keep water out entirely.
Sounds good, but what's the catch?
The catch is that these barrier systems require ongoing, meticulous maintenance to be effective in resisting solar radiation, thermal movement, and cracking. If that seal fails, even slightly.
Water gets trapped inside. Rot, mold.
Precisely. They're unforgiving. One tiny crack and the whole system can be compromised.
So what's a more learning approach?
Rain screen systems represent that. They incorporate a ventilated air gap behind the exterior cladding. This allows moisture that inevitably penetrates the outer layer to drain away harmlessly.
Ah, so there's a gap for drainage and drying.
Yes. The interior weather barrier provides a second line of defense, but the crucial part is the air gap. It ensures that any moisture that does get in can dry out quickly, rather than being trapped.
That sounds much more forgiving.
It is. It makes them far more resilient over time, offering a building a self-regulating skin that can adapt to imperfections and the inevitable degradation of seals over time. It shows how intelligent design can reduce reliance on perfect, continuous maintenance.
That brings us to how buildings were put together historically. I remember reading about the incredible precision of Gothic builders in the Middle Ages. What made their methods so robust and inherently learnable, almost designed for centuries?
The Gothic builders achieved remarkable precision through an incredibly meticulous construction method. Essentially, each stone was finished, molded, and sculptured before being laid.
So they weren't just carving it on the wall.
No, not at all. Each block was custom prepared on the ground by highly skilled masons, then hoisted and fitted perfectly into place. This method created very skillful and intelligent masons who understood the exact role and form of each piece.
And the decoration.
Crucially, it ensured that the decorations suit each piece of stone, because the ornamentation was intrinsic to the stone itself, not merely applied later. The key takeaway is that the construction, decoration, and apparent form were all inseparable.
There was an intrinsic integrity.
Exactly, an integrity and coherence to how the buildings were conceived and executed. Every component was designed and crafted to perfectly fulfill its structural and aesthetic role, fostering incredible longevity and structural honesty.
But then something changed dramatically during the Renaissance, didn't it? And that shift in construction methodology, ironically, impacted the long-term coherence and learnability of those later buildings.
Yes, a significant shift occurred. During the Renaissance, new architectural forms and a renewed interest in classical orders led to a different approach. Moldings and carvings began to be executed in place on roughly shaped stone, often after the stone was laid.
So carving on the wall, basically.
More or less, yes. A departure from the Gothic method of pre-finishing each piece. This shift, however, as Brand highlights through historical accounts, led to a total want of harmony between the jointing and the architectural feature.
Why? What was lost?
Well, when the necessity of making the joints the structural logic accord with the architectural features was no longer imperiously felt, as one source puts it, that principle was lost.
So the decoration became superficial.
It became more like superficial applique rather than an integral part of the structure. This directly impacted the quality and inherent integrity of the building. Arguably, it made it less learnable or coherent over time as the structural logic and aesthetic detail became decoupled,
The building's skin and structure started to shear in a problematic way.
leading to less harmonious aging and more challenges for future adaptation. The layers weren't speaking the same language anymore.
And what about modern best practices? How do we build now to help buildings be more environmentally responsive and resilient, allowing them to better interact with their environment over decades?
Modern best practices place a strong emphasis on the building envelope itself, the walls, roof, and windows that separate the interior from the exterior.
Okay, the building skin again.
Right. Things like thermally broken frames and insulating glass for windows are crucial to manage heat transfer, preventing heat loss in winter and heat gain in summer.
And for walls.
For walls, permeable exterior sheathing and permeable building paper drainage planes are key to managing moisture. These materials allow water vapor to escape from the wall cavity while preventing liquid water from entering.
So letting the wall breathe, essentially.
Exactly. These elements collectively contribute significantly to a building's thermal performance, managing heat loss or gain, and interior moisture levels. This directly impacts energy consumption and indoor air quality.
So by proactively designing these elements,
We enable a building to learn and respond intelligently to climatic conditions over its lifespan, leading to both comfort for occupants and long-term energy efficiency, reducing its environmental footprint for generations. It's about creating a responsive, self-regulating skin for the building.
okay, so if we accept this premise that buildings are never truly finished, but are instead dynamic, learning entities constantly adapting, what does that mean for the practicalities? Managing them day to day, year to year.
Yeah, the how-to.
And how can cutting-edge technology help or even hinder this continuous evolution over their long lifespans?
This leads to a really profound shift in mindset for everyone involved, from initial planning right through to daily operations.
Not just the architects.
No, everyone. Owners, managers, occupants. It requires a fundamental commitment to a building's entire life cycle, recognizing that design and construction decisions made today have implications far down the road, potentially for centuries.
So it's about proactive, long-term stewardship.
Exactly. Seeing the building as an investment not just in real estate, but in an evolving asset.
Here's where it gets really interesting, because it starts even before ground is broken. Even the early stages of a project, long before physical construction begins.
Before the concrete is poured.
Right. Those early stages set the stage for how a building will learn and adapt over its lifetime. It's not just about the blueprints or the budget anymore, is it?
Not at all. Effective project management is increasingly looking beyond mere construction completion and initial cost. Initial planning now commonly considers a broader set of concerns,
Like what?
evaluating social and environmental impacts in addition to the financial impacts. This is often referred to as the triple bottom line.
Social, environmental, financial.
Okay, so asking, how will this building affect the community, the planet, and the economy, not just the project budget? A product life cycle assessment, LCA, for example, is becoming standard practice.
LCA. What does that assess?
Yeah. It evaluates the potential environmental impacts of a product, process, or system throughout its entire existence, from raw material extraction to disposal or recycling.
Cradle to grave, or even cradle to cradle.
Exactly. This directly influences design for sustainability, toxicity, and the environment. It pushes designers to consider materials that can be recycled, are low in embodied energy, are non-toxic.
So this proactive, comprehensive approach is essentially designing in learnability from day one.
Pretty much. Laying a groundwork for a building that can respond gracefully to future challenges, environmental shifts, and evolving social values. It's about thinking several moves ahead.
So the groundwork for a learning building is truly laid before physical construction even begins. What about once the building is physically complete and transitions into its operational phase? How is that ongoing care and knowledge transfer managed to ensure its continued learnability?
That transition to operation is absolutely critical for maintaining a building's learnability and ensuring its long-term health. This is where as-built documentation and record drawings become invaluable.
The final blueprints.
More than that, they aren't just technical documents. They are the building's autobiography, meticulously maintained by the contractor throughout construction and inspected monthly to ensure accuracy. They capture all the changes and details that occurred during construction.
Like where pipes actually ended up, not just where they were planned.
Exactly. Hidden pipes, final finishes, everything. Upon completion, these documents, along with all warranty, guarantee, and operation and maintenance manuals for every system and material, are formally submitted to the owner.
The building's instruction manual, essentially.
A very detailed one. This provides crucial information for ongoing management, troubleshooting, and future adaptations. Furthermore, the construction manager often oversees specialized training for building maintenance personnel.
So the people looking after it know what they're doing.
Right. It ensures they have not only the manuals, but also the practical knowledge to care for it, understand its intricate systems, and effectively implement future changes. This whole, often overlooked process ensures that the information needed for future adaptation is preserved and passed on.
Instead of being lost, which must happen all the time.
It's a common cause of building decline, definitely.
And as we talk about long-term thinking and life cycle management, sustainability clearly emerges as a central guiding goal for these learning buildings. How are these principles being formalized, and what tangible impact are they having?
Sustainability is absolutely a long-term goal for a learning building. It's about ensuring the building remains viable, healthy, and responsible for generations. Organizations like the U.S. Green Building Council, with its LEED Green Building Rating System,
ELED, yeah, people have heard of that.
and the Green Building Initiative, GBI, with Green Globes, they're driving the adoption of sustainable practices and setting clear, measurable standards.
And does it actually make a difference?
It does. For instance, a California study showed that projects designed with these principles in mind achieved 25–30% more energy-efficient buildings.
That's significant. How?
Well, this efficiency isn't achieved by a single silver bullet. It comes from taking a holistic approach, considering everything from energy-efficient heating and cooling systems to advanced control systems that optimize performance, comprehensive foundation, and roof insulation.
Efficient water fixtures, clean materials.
Exactly. Locally sourced materials, minimizing transport impacts. It even extends to deconstructing all existing structures with substantial recoverable materials on a site, minimizing waste, and promoting a circular economy.
So taking old buildings apart carefully to reuse stuff.
Right. These are not just fleeting trends. These are systemic strategies for long-term viability, reduced environmental impact, enhanced occupant health, and a building's enduring relevance. They ensure a building learns to tread lightly on the planet.
It sounds like managing all this constant change and continuous improvement could be incredibly overwhelming, though, especially for large, complex structures meant to last for decades or centuries.
The complexity is immense, you're right.
But new technologies are emerging that seem almost perfectly suited to this never-finished philosophy.
Technology is truly revolutionizing how buildings learn and evolve. Building information modeling, or BIM, is a prime example.
BIM. Okay, what is that exactly?
It represents a paradigm shift from drawing to modeling. This isn't just about making static 3D representations. It's a multidisciplinary design, analysis, construction, and facilities management technology.
So it's more than just a digital drawing.
Much more. It fundamentally changes how projects are conceived and executed. It facilitates and is facilitated by a concurrent shift from traditional competitive project delivery models to more collaborative practices.
More collaboration.
Yeah, it's a unified digital model that everyone involved, architects, engineers, contractors, owners, can access and contribute to. It transforms how we understand and manage a building throughout its entire life, from concept to demolition.
So BIM is much more than just a fancy digital blueprint. It's a living, evolving database of the building itself.
That's a great way to put it, a living database. And its capabilities are truly dynamic, extending across multiple dimensions.
Dimensions, like 3D.
Beyond 3D, its 4D capability, for instance, integrates schedule data with the model. This allows for visualization of construction sequences, identifying potential bottlenecks or deviations from timelines. It's a great tool in time management.
Okay, so 4D is time. What else?
Well, 5D BIM integrates cost data. This allows for real-time cost estimation and budget tracking as design changes are made.
5D is cost. Got it.
6D BIM incorporates sustainability information, enabling analysis of energy performance, material life cycle impacts, green building certifications, that kind of thing.
6D is sustainability.
And 7D BIM focuses on facilities management. It provides asset information for operations, maintenance, and space planning throughout the building's operational life, the as-lived phase.
So it helps manage the building after it's built.
Exactly. And during construction, the BIM model is continually updated to reflect existing conditions, incorporating information from subcontractor shop drawing submittals and clash detection.
Clash detection.
Yeah.
Finding problems before they happen.
Precisely. Identifying conflicts between different systems, like plumbing running into electrical conduit in the model, before they become costly on-site problems. This continuous updating and proactive problem solving are fundamental to fostering a building's ability to adapt and learn in real time.
Ensuring a smoother transition and a more resilient, well-documented structure.
Right.
That's incredible for the construction phase and long-term management. But what about once the building is occupied? Are there technologies that enable a building to learn from its occupants and environment on an ongoing, almost day-to-day basis?
Absolutely. This is where smart buildings and dynamic responsive systems truly come into play. They embody the idea of a constantly learning structure.
The building itself becomes smart.
In a way, yes. We are moving from living in a home to living with a home. Sensor networks are the key enabler here.
Sensors everywhere.
Strategically placed, yes. Creating feedback loops that bring architecture to life based on a dynamic set of experiential and functional requirements. Imagine your building reacting to you, learning your preferences and habits.
Wow. How does that work?
These responsive digital systems can control everything from energy generation to demand and distribution. For example, sensors can detect occupancy levels and adjust HVAC and lighting accordingly, ensuring energy isn't wasted in empty rooms.
Saving energy automatically.
Right. They can monitor air quality, proactively opening vents or filtering air. They can track equipment performance to predict maintenance needs before a breakdown occurs.
Predictive maintenance. Very cool.
This allows buildings to learn from and coexist with their occupants, adapting to their presence, their preferences, and the external environmental conditions in real time. This transforms architecture into a form of interface.
An interface between the physical and digital.
Exactly, connecting physical and digital realities and enabling what's called spatial cybernetics, essentially the study of how information and control systems interact with physical space. It allows the building itself to regulate and adapt, becoming almost a digital extension of its physical form.
So it's about creating a truly symbiotic relationship where the building actively works to optimize comfort, efficiency, and safety.
That's the goal.
That's a profound shift, making buildings responsive, almost sentient partners in our lives. So what does this all mean for us? The people who design, build, and inhabit these structures, it seems to demand a certain kind of engagement.
It does. It goes beyond just using a space.
Yeah.
It implies a deeper responsibility.
Us.
Ultimately, the learning of a building depends fundamentally on human attentiveness and a commitment to continuous improvement. No matter how advanced the technology, human engagement, observation, and care are the bedrock.
Buildings don't learn in isolation. They learn through us.
Exactly.
That reminds me of Matthew Crawford's idea of the mechanic's mindset. It's about a particular kind of relationship with the objects we interact with.
Yes, exactly. In Shop Class as Soulcraft, Crawford describes how a good mechanic internalizes the well-working of the motorcycle as an object of passionate concern.
It's not just fixing things when they break.
No, it's about a deep, almost personal responsibility and an ongoing engagement with the nuances of how something performs. He states that the truth does not reveal itself to idle spectators.
You have to get involved.
Right. This implies that we need to approach buildings with a similar dedication, an active, responsible engagement with the ongoing needs of our built environment. We can't just be passive users. We need to be attentive stewards, constantly observing, understanding, and responding to the building's signals and evolving needs.
And to manage such complex, evolving systems where every decision has ripple effects across those shearing layers we talked about, we need a particular way of thinking, don't we?
We do, beyond just individual parts to the interconnected whole.
Like systems thinking.
Indeed. To navigate this complex, interconnected world of evolving buildings, we need to embrace a thinking in systems approach, as Donella Meadows brilliantly describes it. This means we must take your eyes off short-term events and look for long-term behavior and structure.
See the big picture, the patterns over time.
Right. It's about seeing the patterns, the feedback loops, the underlying dynamics, rather than just reacting to individual incidents. We need to understand concepts like resilience, how a system can absorb disturbance and still retain its function.
like a building weathering a storm or adapting to a new use.
Exactly. And self-organization, how systems can create new structures and behaviors, and hierarchy, how smaller systems are nested within larger ones, like those shearing layers.
And crucially, we must avoid.
We must avoid bounded rationality. That means decisions that make perfect sense within one small part of a system, like, say, saving money on a cheap exterior skin,
Okay.
but are not reasonable or beneficial when seen as part of the wider system, for example, leading to massive energy bills and maintenance issues later on because that cheap skin performs poorly.
So every decision, every change has ripple effects throughout the entire building system.
You have to think about those ripples.
So it's truly about seeing the forest, not just the trees, in the architectural sense, and thinking about the long-term systemic impact of today's decisions. Can this systemic thinking actually help us solve problems before they even arise, almost designing out future issues?
It absolutely can. This is where the proactive power of systems thinking truly shines. The theory of constraints, TOC, for example, which comes from manufacturing but applies here.
TOC, from the goal.
That's the one. It has been successfully applied to the design of new plants and production lines to solve problems before they arise. The core insight is that every system has a bottleneck or a constraint that limits its overall performance.
Find the weak link.
Find the weak link, exactly. By identifying and strategically addressing these constraints at the design stage, you can dramatically improve the system's efficiency and adaptability from the outset.
So it's about understanding the logic.
Yes. The principle here is that if you understand the logic and the reason behind the methodology, then you can apply that stuff continuously to foster ongoing improvement and adaptation. This proactive problem-solving, informed by a deep understanding of systems and constraints, is essential for truly designing buildings that learn and adapt gracefully throughout their very long lifespans.
Minimizing future conflicts and maximizing their potential to evolve with us.
It's about building in a capacity for continuous optimization right from the start. Hashtag outro.
Wow, what a journey we've taken today. We've truly explored this radical idea that buildings are not static objects, but dynamic processes, constantly adapting, evolving.
Almost like living entities interacting with their environment and us, their occupants.
From Stewart Brand's brilliant concept of shearing layers of change, which reveals the different paces at which a building's components evolve.
To his categories of high-road monuments and low-road adaptable structures, we've seen how buildings tell their stories through transformation, use, and sometimes even struggle.
And we've looked at fascinating historical examples, like the humble yet adaptable painted ladies of San Francisco and the biography houses of America's founders.
Contrasting them with how architectural changes, like those at St. Peter's Basilica, can make a building fight its occupants.
We also delved into the deep impact of construction practices, from Gothic precision to Renaissance compromises, and how modern material science contributes to a building's ability to respond intelligently to its environment.
Moreover, we've seen how cutting-edge technologies like building information modeling, BIM, and responsive smart systems are fundamentally transforming project management, moving from traditional drawing to dynamic modeling.
And creating powerful feedback loops that allow buildings to truly coexist with their occupants.
Which demands a new kind of human engagement, right? That mechanics mindset and a thinking in systems approach, where continuous improvement and proactive problem-solving become paramount.
The crucial lesson, reiterated throughout Brand's work and our deep dive today, seems to be designed not just for perfection on day one, that fleeting moment,
but for a lifetime of change. Accommodate the inevitable needs for maintenance, renovation, and even entirely new uses that we can't possibly foresee at the moment of conception.
It's about humility in design, really.
Indeed. We must foster resilience, flexibility, and a capacity for adaptation from the very start, acknowledging that a building's greatest strength might lie not in its initial immutable form, but in its profound capacity for graceful, continuous transformation.
Empowering buildings to learn.
Exactly.
So, as you go about your day, perhaps look at the buildings around you a little differently. What if we stopped seeing them as monuments to a single moment fixed in time?
And started seeing them as living, breathing entities that continually adapt and evolve with us, their occupants.
How would that change our built environment, and even our relationship with the spaces we inhabit?
And what responsibility does that place on you as a user, a designer, a developer, or simply an observer to foster that ongoing learning and evolution in the structures we build and inhabit?
Something to think about. Thank you for diving deep with us today.